that connect sine and cos. All right, co-functions connect sine and cos, and they are also part of reduction, but they are a special group of reduction formulae that are called co-functions. Right? Some resources or textbooks, they also call them co-ratios. Okay, so here we can call them co-functions or co-ratios. And the co-ratios is mainly sine and cos. Now, so this is how it works. You know this probably a little bit. If I give you sine 30 degrees, we know that the ratio is a half. Right? If I give you cos 60, the ratio is also a half. Now, there is a relationship between these two angles here. If it's sine, it will be 30 degrees, it will give you a ratio of a half. If it's cos, it will be angle of 60 degrees, it will give you a half. Now, what that means is, to get this 60 degrees, we subtracted the 30 from 90, and vice versa. All right? To get the 30, you can subtract 60 from 90, and you get the same ratio. So we can come up with a formula for that. Also here, cos 30, we know it's square root of 3 over 2 from last year. And sine 60 is also equal to square root of 3 over 2. Again, if you subtract the 30 from 90, you get 60. If you subtract the 60 from 90, you get the 30. There is a relationship. All right? Now, that relationship, we can summarize it. If I give you, say, 50 degrees, okay? If it's sine 50, we can rewrite it using cos. By subtracting the acute angle from 90 degrees, we get 40 degrees. So what that means is, sine 50 degrees is equivalent to cos 40 degrees. This only works in the first quadrant. Okay? It works in the first quadrant. Right? So sine 50 is the same as cos 40. If I give you cos 50, it's the same as sine 40 degrees. Right? And so on. So as long as you've got an acute angle, okay, the sine of that acute angle is equivalent to the cos of 90 degrees minus the acute angle of the sine ratio. Okay? So we can come up with a relationship, and that relationship can be summarized as the sine of an angle is equal to the cos of the complementary angle. Okay? Also, the cos of an angle is equal to the sine of the complementary angle. Now, this, we generally summarize it mathematically. I'll show you on the next page. So, sine theta is equivalent to cos 90 degrees minus theta. And also, cosine of theta is equivalent to sine of 90 degrees minus theta. Okay? Why do we need co-ratios? Now, there are scenarios in trigonometry at this level and beyond where you might need to simplify a trigonometric expression completely. In some questions, they require knowledge of co-ratios. Okay, so we use co-ratios to move from sine to cos or cos to sine. Okay, that's the basic idea. So we call them co-ratios, or we can call them co-functions. So if you hear me saying co-ratio, I'm referring to co-functions, and vice versa. Okay, that's why I actually added that there. All right, so we have got those two. So now we have got 17 now. Okay, reductions. Remember, yesterday we had 15, quadrant 1, 2, 3, and 4, and the negative angles. Sine minus theta is equal to minus sine theta. Cos minus theta is equal to cos theta. Tan minus theta is equal to minus tan theta. That's 15 from yesterday. Then we have got 2 here. Okay, co-ratios. As the co-ratios, now these ones there, they also have made, you can call them sisters and brothers, whereby instead of putting a minus here, you can put a plus and a plus there, and you come up with a new group with another set of co-ratios. Right? Then you also bring in 90 degrees. So if so far I've written for 90 minus theta, and we have got these two. I just wrote these two for you. Okay? Be aware that 90 minus theta is in the first quadrant. Okay? If we reflect 90 minus theta, it will end up being in the third quadrant. It means we are adding 180 degrees. and we come up with another angle which is 270 minus theta. Okay, I'll come back to that. Now, let's come to the next group. Now, it's also possible that if you are given, say, sine 90 plus theta, you can convert that to cos. Okay? But the conversion now, this is how you do it. If I give you an angle, say like sine 130 degrees, if I ask you to write sine 130 using an acute angle and cos, this angle here, we can split it up and write it as sine 90 degrees plus 40 degrees. Okay? Remember, the purpose of reductions is to write trigonometric ratios of non-acute angles using acute angles. That's the basic idea behind reduction formula. So we can break it up like this. Okay? We could also subtract this 130 from 180 and get sine 50 degrees, but I don't want to convert the sine 130 to sine of an acute. I want to convert the sine of 130 to a cosine of an acute angle. So this now is going to be equivalent to, since this angle here is in the second quadrant and sine is positive, right? Please make sure you are looking at sine 130 is positive because 130 degrees is in the second quadrant. So if I want to convert the sine of 130 to the cos of an acute angle, that cos of an acute angle, it has to be positive so that the ratio of sine 130 remains positive. Therefore, we neglect this 90 and then we just write this as cos. Okay? Write this as cos 40 degrees. You can verify this with your calculator. Sine 130 is equivalent to cos 40 degrees. Now, the interesting thing is, the co-ratios which I just mentioned earlier, this first set here, okay? If I can convert this cos 40, it will give me sine 50 degrees, okay? Which is what I can come up with if I move from here straight away to sine 50 degrees. If I use the reductions that I spoke about yesterday, we can move from sine 130 to sine 50, but we can also move from sine 50 to cos 40 and vice versa. Okay? I hope you have been going over your work from yesterday. Okay? So there is a relationship, okay? The reductions that we did yesterday and the co-ratios, there is a relationship. So I move from sine 130 to cos 40 degrees. Okay? Be aware that sine 130 is positive, therefore, if I convert it to cos, it will be cos 40, but the cos 40 degrees can also be written using the first set of correlations as sine 50 degrees. And sine 50 degrees is equivalent to sine 130 from yesterday's reduction. Okay? So that's what we have there. If you do that for cos, it's the same thing, but the idea changes slightly now. Okay? Because cos is negative in there. If I give you cos of 130, it's a negative ratio because 130 is in the second quadrant, right? So I can write this as cosine of 90 degrees plus 40 degrees. Okay, remember from yesterday, I can convert this cos 130 to the cosine of a negative angle, but I want to use the positive one. So this will be sine minus sine 40 degrees. It becomes negative because the cosine of 130 is actually a negative. So if you want to write in terms of sine, you have to put a minus there to make the ratio a negative ratio. All right? Now, from yesterday, we know that this is equivalent to minus cos 50 degrees. All right? We know. Now check this. This part here is the same, right, from the first group of correlations. Sine 40 is equivalent to cos 50 degrees. So there's a connection now. 90 minus theta and 90 plus theta, also 180 minus theta from yesterday. There's a relationship. All right? So, talking about that, we have got that. So how many do we have now? 19, right? So we've got sine 90 plus theta, cos 90 plus theta. Right? So we've got 19 reductions. All right? Now, if you do a reflection now of 90 plus theta, you get in the fourth quadrant, you get 270 plus theta. Or you can just add 180 degrees clockwise or anti-clockwise, you get here, right? Also, for the 90 minus theta, add 180, either clockwise or anti-clockwise, you come to the third quadrant. Now we can also write, we also have co-ratios for 270 minus theta and 270 plus theta. Right? Now, let's start with sine. Now, sine 270 minus theta, right? Because sine is negative in the third quadrant. It means sine 270 is what I'm going equivalent to minus cosine of theta, because cosine here in the third quadrant is also negative. Both sine and cos are negative in the third quadrant. Therefore, we can sine 270 minus theta is equivalent to minus cos theta. And the reverse is true. Cos 270 minus theta is also equal to minus sine theta. Right? But, okay, this set here is a very rare one to encounter. It's mainly the first two, especially the first one. That's the most common. Yes.
Okay, so for the first two sets,
Yes.
for the first four, does that only apply for which theta itself is less than 9?
All the values of theta are acute. For all our reductions, theta is acute. Is that clear to everybody? Yeah. The definition of reductions, it is just a group of formulae that can be used to reduce trigonometric ratios of non-acute angles to trigonometric ratios of acute angles.
Okay, so for example, if you had sine 200, you would not use this.
Well, you can use the reduction that we used yesterday. One can also use the correlations. You get to the same result. Okay, let me show you. So we're talking about 200, right?
Yeah, okay, so if you have
You want sine 200. Okay, sine 200 from yesterday, sine of 200 degrees. We can break this up and write the sine 180 because it's in the third quadrant. Alright? From yesterday, this will become minus sine 20 degrees.
Yes.
Alright? Then the same sine 200. If we want to use co-ratios, we cannot use 90 plus theta because that angle there is more than 180. So it's going to be sine 270 minus 70 degrees. Okay? Right? Now, if we use co-ratios, sine 270 minus 70 degrees, if we use co-ratios, we are converting sine to cos. Please be aware of that. The idea behind co-ratios is working with sine and cos, converting sine to cos and vice versa. So I have to convert this sine of 270 minus 70 is going to be, you don't have to stress, this acute angle here becomes cosine of that acute angle. But be aware that 200 is in the third quadrant and cos is negative. So our answer here will be minus cosine of 70 degrees. Right? We're following that. Then check this now. The sine 120 and the cos 70 degrees, based on the first set of reductions, they are equivalent. So in the end, you come to the same result. So as teachers, in a test, if someone, okay, converts this to that, this is the correct answer in terms of sine, right? If someone uses co-ratios, you can't stop here. You now need to convert the cos 70 to what? To sine 20 degrees. Using co-ratios, you will get full marks either way. Okay, you get full marks because you would have used the correct reduction formula concept. So here is the general reduction formula, and then here it's a combination, co-ratios. Okay, did I answer you? Right. I hope you're following. Those are the good questions to ask. I've clarified it. Right? So we have 270. So then we've got 270 plus theta. Now, if it's 270 plus theta, it means we are in the fourth quadrant. We are in the fourth quadrant. So sine 270 plus theta, you convert it to cos. But because sine is negative in the fourth quadrant, if you write it using an acute angle, it becomes minus cosine of the acute angle. So that's what we got there. So sine 270 plus theta is equivalent to minus cosine of theta. Also, cos 270 plus theta is the same as positive sine theta because 270 plus theta is in the fourth quadrant and cos is positive. Therefore, we can't put a minus here, we have to put a plus so that the resulting ratio is going to be a positive ratio. Okay, please be aware that cos is positive if the angle is reflex in the fourth quadrant. Okay, therefore, cos 270 plus theta is equivalent to sine theta. All right, so we've got 8 here plus the 15 yesterday is 23. Right, reduction. Don't get scared. Next year, when you do what's called compound angles, this will become much simpler. Okay, but unfortunately, we can't teach you compound angles in grade 11. Right? In grade 11, it's about memorization and understanding the concepts and the relationships. Okay. Any question? Any question? Right? I want you to be aware that you are supposed to memorize and you've got the capacity to do so. Okay? Your brain needs to be stretched because it's elastic, so it adapts. If you tell your brain that no, I can't memorize, then it will also say, oh, I can't memorize. If you tell it that I can memorize, then it will adapt and it will memorize. When you write a test, okay, there is no way where you see an information sheet for reductions. You are supposed to be the information sheet in your head. Okay? So never say, this is too much. It's not. You have got the capacity to memorize. Okay? All right. All right. Let's start with let's start with the first one, A1. Right, so you've got cosine of 90 degrees plus theta divided by sine of negative theta. Okay? Now, you need to be aware that 90 plus theta is a co-ratio. Cos 90 plus theta is a co-ratio. 90 plus theta, if theta is acute, it's going to be an angle is in the second quadrant. And in the second quadrant, cos is negative. But we have to convert the cos to sine, so this becomes minus sine theta. Right? And then sine of negative theta, the negative theta is in the fourth quadrant. If theta is acute, so this is the same as minus sine theta. And your answer there is going to be positive 1. Okay? All right? So that's the first one. That's simple. Okay? Then let's do number 4. Can't do every question. But sine 360 degrees minus theta plus cosine of 90 degrees plus theta. This is all over sine of negative theta. Right? So from yesterday, sine 360 minus theta, okay, the 360 minus theta is in the fourth quadrant, and in the fourth quadrant, sine is negative, so this will be minus sine theta plus cos 90 plus theta, well, that's a co-ratio, and cos is negative in the second quadrant, so this will be minus sine theta. This is all over. Now, sine minus theta, we know that this is minus sine theta. If we simplify this, we'll get minus 2 sine theta divided by minus sine theta. And the final answer is going to be positive 2. Okay, now a question like this one here, it will probably be 4 marks. Okay? It will be 4 marks. So the first mark is for knowing that 360 minus theta, sine 360 minus sine theta, and then cos 90 plus theta is a co-ratio, which is going to be equal to minus sine theta, and then sine minus theta is equivalent to minus sine theta, and the answer. So you will get about 4 marks for a question like that. Usually, questions on reductions, they've got lots of marks. Okay, some can have 7 marks, 1 question. Some can have 8 marks, 1 question. All right. So if you know your reductions and you can get all the marks, then you will definitely be able to pass. Right? If you are writing a test. Okay. Are you following that? Yeah, it's all about memorization. Of course, there has to be understanding, and you also need to know your quadrants. Be a master of your quadrants. Right? What?
Nothing.
Okay. Let's do one more. The one with tan now. Okay? Later we are going to do an identity which involves tan, but I cannot use it at this stage. Okay? That's maybe for tomorrow or so. So we have got sine 90 degrees plus beta. Okay? Yes, beta. Right? Times tan minus beta minus sine beta minus 90 degrees. Right? Times, it's quite long, times tan 180 degrees minus beta. Right? It is long, like this means that you can get 4 marks for reducing all those expressions. Yes, so the numerator, simplifying the numerator, then the denominator is tan 360 degrees minus beta. Okay, so let's use reduction formula and co-ratios together with negative angles. So sine 90 plus beta, always be aware that if there is a letter, whether it's an English letter or a Greek letter, that angle will be acute. So beta here is an acute angle. And we have got sine 90 plus beta, this is a co-ratio. So we have to convert sine to cos. But 90 plus beta is in the second quadrant. In the second quadrant, sine is positive. So this will become cos beta. Okay? Times, right? Now, tan minus beta from yesterday is equivalent to minus tan beta. Right? Minus. Now, this one here, you need to be very careful how you work with it. But it's very simple. I'll just show you how to simplify it. You can't do it mentally. Okay? Just to let you know, if you want to do this mentally, beta is acute in the first quadrant. So if you are in the first quadrant, you move 90 degrees clockwise. Okay? If this is acute, means you end up being in the what? Fourth quadrant. And sine is negative in the fourth quadrant. But the good thing is we can convert it to cos, but I'll show you how. So sine beta minus 90 degrees. We can just add 360 to that whole angle. So this becomes sine of beta minus 90 degrees plus 360, right? And we will end up having sine of beta plus 270 degrees. Now we are coming to co-ratios. The moment you see a 90 degrees or a 270 popping up, right, it means that you have to use co-ratios, right? So this, it's in the fourth quadrant, and in the fourth quadrant, sine is positive, so we can write this as cos is positive, so this will become cos beta. Okay, actually minus, because the sign is negative, so it becomes minus cos beta. Are you following that? Okay, it becomes minus cos beta because the sign of an angle in the fourth quadrant is negative. But you want to rewrite using cos of an acute angle, so we have to put a minus cos beta. Right? Now be very careful with the reductions because you can make a silly mistake of a sign. That's very common. So you have to be very careful. Right? So it means I've got a minus here, then I have to put a minus cos beta. Right? Then times, now tan minus beta is going to be equal to times, now that's in the second quadrant, so that would be minus tan beta. So I've simplified the numerator. Okay, the numerator is simplified. Then the denominator, that 360 minus beta is in the fourth quadrant. And in the fourth quadrant, tan is negative. So this will be minus tan beta. Now, be very careful. You have to be very careful here. We have got subtraction here. Okay? So I need to multiply these two, then I'll also multiply those two. Don't start cancelling out terms because we have got this minus here. So we are subtracting two terms, but we have to get their product first. Remember, multiplication starts first. So cos beta times minus tan beta, right? Okay, let me write it on the next page. Okay, is anybody who's got a question? Any question? Yes. Take
You
it
can
out.
take out negative tan beta.
Okay, explain to me how you are thinking that we should take it out.
Wait, what? We're not good.
Okay. If you say take out, can you use a proper mathematical term for that? Take it. Okay. Yeah, that's one way of doing it, but I don't want to do it that way. But it's fine. You can
Let's see if the answer
you
like
can
right.
factor out
I did
you can factor out minus tan beta. But I'm not gonna do that. Okay, I'll show you how I'm gonna do it. Okay, so if I multiply cos beta times minus tan beta, I'm going to get minus cos beta times tan beta. Right? Minus. Okay, the minus that I put is this one here. Then minus cos beta times negative tan beta, I'll get another minus. Actually, it's a positive cos beta. So this will be cos beta times tan beta. Right? This is all over. If you have got any issue, you must tell me so that I can clarify this.
So aren't you supposed to change the negative, the minus at the top to it?
No. The reason why you don't have to change it because see this negative here, that's for subtraction. But then this cos beta is negative, that tan beta is negative.
Oh, so they cancel out
Yes.
the original one.
Yes. Right. Then when you get here now, if you want to factorize like what Mtempo was saying, you can factorize it. But I'm not going to factorize. They are like terms. Do you see them? It's like if I give you minus xy minus xy, what is the answer? Minus 2xy. So that's the same thing. So that numerator, and by the way, your trig requires depth of algebra, right? You need algebra in trig. Okay, so you can treat that cos beta is x, the tan beta is what? Is y. So this becomes minus cos minus 2 cos beta times tan beta. This is all over minus tan beta. Since we have one numerator, one denominator, okay, I can just cancel out these two. And this negative and that negative will also cancel out. So my final answer will be 2 cos. Okay. You can also factorize from this step. You can factor out tan beta or minus tan beta. You should come here.
I always take the easy.
Okay.
I will always take the easy. Always.
Okay. Now, just to let you know, I also could have, okay, we haven't done the two fundamental identities for trigonometry yet, but I can convert this tan to sine over cos, the tan to sine over cos, and then that cos and the cos which comes from here, they will cancel out. Also there, they will cancel out. So in the end, you are going to end up having a minus sign on top, okay, minus another minus sign, and you cancel out this minus tan beta, right? You end up getting a different expression from this. But well, let's not go there.
When you get them on.
That's for another lesson.
But we
Yeah,
can get them on.
you should get full marks, depending on how the question is. Okay, any question? Any question? You don't have any question? Okay. Alright, what I'm going to do as a class exercise. Can you do number 3 here? It's a class exercise. Number 3. Yeah, if you can survive this grade, then you are gonna pass matric next year.
What do you mean if you survive?
Yes.
What state you say the sun of
What is the what?
the date of the sun?
26th of April.
Wait, so let's check if this is right.
Cos x minus 90.
Yeah.
Cos x minus 90 is in the fourth part.
No. Or just from the beginning of this. From where it's cos x minus 4.
Cos x minus 450. So you add the 360, yes. Right. Then you get minus 90. Everything is always okay. Whereas you see, cos x minus 90 is in the fourth part. Cos is positive. Cos x minus 90 in the fourth part is positive. So we are supposed to get a positive answer. You know how you got the minus. You see here, where it says cos minus 90 minus x. Supposed to be a positive.
Oh,
cos 90 minus x. Yes.
Okay. Everything is happening together with everything else.
Is the end, but we finished. Is the end, but we has finished. Right, we only have 5 minutes, so you should finish by now. You should finish.
Yeah. I'm finished. This is all I'm gonna do for this lesson, I swear. I'm finished.
Oh, about what you got? What did you get? Oh,
I got negative 2.
what did you get? I got 1.
I'm so confident in mine, but what? Am I right? Am I wrong?
I took it all as a common factor, right? Because it's minus sine x times minus sine x. Oh, come on, John, don't do that. Come on. What did you do?
I'll just
Oh, yeah. I'm thinking with So I got one. Cos of the negative angle is
Yeah,
cos.
it's negative too. Can I see where the
I didn't work out that well.
I need to check it because this is fine. That one minus sine and this one minus sine with a plus here. Then to reduce this, when it's positive sine.
Oh.
Okay? You see why is it positive? Because if the cos of x minus 450, right? It's always better to add 360 degrees, right? Then you get cosine of x minus what? 90 degrees. Now, this one here, we can simplify further. There is more than one way. You can add another 360 if you want, right? So if you add another 360, you end up getting cos of x plus 270. The moment you've got this 270, you now have the what? Co-ratio, right? And this is the same as cos 270 plus x. Now, 270 plus x is in the fourth quadrant. In the fourth quadrant, cos is positive. So if you want to convert it to sine, it becomes sine what? Sine x. Right?
Yes, sir.
So make sure you work and you go home and work on that.
Okay, sir.
And you know that a negative angle will always be equal to theta always this not. Yeah. So the negative angle will always be here.
Thank you, sir.
All right, see you.